organization. Okay, I'd like to introduce Zane Durante, is a PhD student in computer science and advised by Dr. Eshin Adeli, and Dr. Feifei Li. His research interests include self-supervised learning, multimodal signal processing, and AI for healthcare. Zane?
All right, it's really nice to see you all today. Am I good on the mic for the people in the back? Okay, great. So yeah, I'm going to be talking about ambient AI, which is a subfield of AI that some of you might not be super familiar with. And I'll be presenting the work that I've done and also the work of some of my collaborators as part of the Stanford Translational AI Lab. Cool, so just to broadly define ambient intelligence, it's a subset of pervasive computing, which is this notion that if you have a physical space with people in it, you can embed devices within that space. We already do this in our home with things like thermostats and other sensors. A lot of people have recently been doing smart home devices like the Alexa is probably the most commonly used ambient intelligence device. But really, you can attach all sorts of sensors like cameras or LiDAR sensors and combine these with user interfaces to allow users in these environments to also interact with the sensory data. The overall goal is to build like a physical environment that's context aware. And eventually, you can actually build an AI that understands the physical space and everything that's happening within it. So this is what ambient intelligence is. You can think of it as AI for a specific physical space. All right, our group has mainly worked on two types of physical spaces. We have hospital spaces and daily living spaces. Just to briefly go through, I won't spend too long here, but they're very different kinds of environments with very different activities that happen within them. But we've outfitted sort of both of them with these LiDAR sensors and cameras to detect human behaviors and activities that are happening there. As I mentioned before, there's a lot of different things that happen in a lot of different kinds of rooms, which is also a challenge when you're building ambient AI. In general, the overall sort of guiding principle is you want to recognize the behaviors and activities that are happening in the rooms. So this is what we're coming at from a technical side. Now, a sort of more societal question is which activities you want to detect, who's going to use that data, how can we use this to improve people's lives? This is sort of where the clinical meets the technical, and we try to bridge a gap to build something that's useful for patients and other people that could be dealing with really severe conditions like mental disorders and things like that. And yeah, we have a bunch of collaborators here at Stanford working on this exact problem. Cool. I'll do a really brief dive in about what we did at Stanford Hospital, and we're trying to basically do the same thing in home environments. And it's still a work in progress, and we think there are many different applications for this kind of technology. So basically what we have here is like a mock room, a hospital room. You have a patient bed. These are the ICU rooms at Stanford, so the patients are just stuck in bed. And we have these cameras trying to detect subtle changes in the behavior, what actions are the patients doing. And together, we've built this sort of what we call the clinical behavioral atlas. And the idea is to create an automatic way to basically, in a high throughput way as well, understand all the clinical activities that are happening in a room and understand and make sure that the patient is receiving the care that they need to receive and at the right time. To build this model, we basically took 1 year of data from 8 different rooms with the 2 sensors in each room. And you can really visualize the data here. Some were in the hospital for a really long time. Others we only saw for maybe a day or 2. And just to take a brief look under the hood of what can our AI algorithm actually do. We have the ability to basically detect a lot of the important objects in the room, like the vital signs monitor, the bed, and we can also detect, this is a skeleton of the patient, so it's certain key points for the joints. So we sort of know where the person is, what is their pose, are they sitting or standing? And that sort of mobility information is actually really important for knowing, if a patient's been bed bound for hours on end, are they able to sit up with assistance or by themselves? So a lot of this data can all fuel into this more broader understanding and contextualizing the way that the patient is staying in the room, and if they're having any specific issues that might be not addressed or might be unseen if you're just relying on people who walk in and out of the room sometimes and maybe don't have this more holistic picture. Here's another example. We can see the patient sitting. They go into a brief standing state, and then they start sitting in another chair. So through our algorithm, we're basically able to detect this change in state, where it's occurring, and that it's done with the assistance of a doctor here. And also to note, these aren't real patients. These are like people from our lab. So we're not leaking any data here. All right. So what can you do with these sorts of data now that we can collect all these fine-grained details? You can do really interesting plots. So I really like this plot number 1. It's basically a timeline, and you can see all the different activities that people are doing. And you can imagine for something like OCD, where there might be some repeated activity that you can detect, you might actually see specifically a repeated activity many times within a period of time. You can understand how frequently it happens and also how long it's spent on those activities. And this is really nice because it's an objective measure. So a lot of times for neurological disorders, you have to rely on things like surveys. And these are good tools, but they can be slightly, they're subjective, so they're maybe not the most accurate. And this can provide a really nice way to measure things more objectively and plot trends over time, things like this. So I think this is probably one of the more exciting things that ambient AI can do in this particular space. You can also do more gross measures, like break down across a period of time what's everything that the person is doing and sort of average it, like in plot number 2 here. And you can also calculate things like, okay, what times are people doing certain activities, which is shown in plot number 3. Cool. I think I'm going to, I talked a lot about the hospital, and I'm going to talk now more about home environments, where I think it's maybe a little bit more applicable for OCD in particular. I do think in terms of the home environments, this is still more of a work in progress for our lab. We have some initial results, and I'm going to share those with you today, but we really want to try to apply these same methods into this setting. So this is what our ongoing research is doing, and what we're really excited for the future of this sort of technology. All right. One of the important aspects of certain neurological disorders and conditions that we're studying in our group, things like dementia, is you have these neuropsychiatric symptoms that can actually start occurring before an official diagnosis is made. And these are things you can maybe detect with ambient intelligence. So things like a change in the motor behavior, the walking pattern of an individual, just disturbances in their sleep. When are they getting up? When are they going to bed? Also things like, when are they eating? These sorts of things ambient intelligence is very good at. There's a whole range of these NPS, and we can't detect it all with ambient intelligence, but I think it's really neat that just by doing something like strapping a camera on the wall and training an AI algorithm, you can get all of these just with one device. So this is the main buy-in for why ambient intelligence is so interesting and useful from a sort of research perspective. Cool. Yeah, one more thing. We're really working here to sort of integrate it all into an app. So the idea is you could give your doctor or maybe a loved one or a family member access to this information so they're able to see it. We also think that this can do things like help support seniors that either are living on their own or don't want to live in an assisted living facility and have family members help sort of monitor them, but without having to look through the camera 24/7. You allow more autonomy while still tracking important things and making sure that no one is not feeling necessarily looked at by a human all the time. So they have a little bit of freedom, but then they also, there's some guardrails there in case something does go wrong or starts to go wrong. Cool. Yeah. So as I said, we're just getting started here. We have this study that we are starting with 21 participants. I'll go through the details not too in depth here, but basically we take a questionnaire before and after the study. We also do some checkups throughout the study, and we're trying to understand, what are the changes when we have cameras capturing some of the differences in activities during the study as well, and try to see if any of these can be used to correlate. Okay, well, we find that a disturbance in sleep as captured by the cameras is correlated with worse outcomes by the end of the study, something like this. So that could be one potential hypothesis that we're looking into here. To give you a look of what our data can look like, one of the other things we work on our lab a lot is anonymizing the data. So this is a real patient video, but we've completely masked out the human bodies and replaced it with the skeleton poses that I showed earlier in the slides in the hospital bed. So this is nice because it allows us to actually have a pretty good idea of what the person's doing without seeing anything about them. And this can be useful in environments where you might have multiple people living somewhere, or someone might not be comfortable with an outside group seeing them specifically in the scene. They don't want to be identified, but we can still have a human labeler say, look at this video and annotate what the person's doing to train an AI without ever having to see the person itself. So here's another interesting area we're looking into. I talked about the other timeline that I really liked potentially for OCD. Another type of thing that I think could be really interesting is basically building a daily behavioral profile. So you could sort of track, we have 2 participants in this current study, and we're understanding how much time are they spend sleeping during the day or at night, when are they walking, and sort of compiling these into more gross statistics and an overall measure of, how does this person line up compared to other people we've seen? And this can also be a useful way to sort of visualize and understand a patient without having to look through, 4 days of video or something like that. And here's some examples where the 2 patients have very different statistics. Yeah, I think in general, I'm going to go through the rest of the slides rather quickly and pause near the end, just in the interest of time. But really, we do a lot of work in the independent living of seniors. We have all these clinical partners at Stanford and abroad that we've worked with. And there are some really interesting statistics you can get, like mobility, how are people walking? Are they falling? How stable is their movement? All of this can be detected with a camera. You can know when people are at least in bed, when are they trying to sleep? And you can also get an idea of, how often are they eating? How long do they spend eating? How much time are they spend drinking fluids, etc. So there's really a lot you can do. A lot of people, though, don't like the idea of a camera in the room. So this is a pretty reasonable, I totally get it. And so we've spent a lot of time trying to take their, I think, pretty well-founded concerns into consideration with designing our system. So one of the things we do, once we have an algorithm that works, the idea is to deploy the AI at the edge. What does this mean? It's basically you stick a small computer onto the camera and you run the AI model there so that you never have to send the data anywhere. You're just running everything on the camera system itself. So people don't need to worry about, is my data, where's my data going? Who's going to see it? It's all just going to be in that computer there. So this is one way to alleviate concerns because you don't have to transmit the data. There are also just a number of ethical considerations that come up when you're building an ambient AI system. I won't go into all of them, but we've actually written a paper about this a few years ago where we talk about each stage of the process, all the ethical issues that can arise that we could articulate in this paper. We maybe didn't get all of them. And then also some of the pros and cons and what the researchers or the creators of the ambient AI should consider in order to do it in the most ethical way. All right. Yeah, I think this is a really exciting future direction for ambient AI and OCD research potentially. So please reach out if anyone has any ideas or wants to collaborate or wants to help in any of our studies. We're always looking for more people to work with. And I think, just to name a few areas, I think it can be really useful. I think it can be really good for symptom tracking and detecting any behavioral patterns, just more generally. Also progress tracking over time, and even potentially for real-time alerts. I think it could be useful because you can detect sort of the repetitive behaviors potentially right as they're occurring. Another example use case that I think could be really interesting is basically it's a passive behavioral assessment. So the idea is you set up the cameras to be running in the background, and then you can quantify the frequency and duration of all these repeated tasks. And this is really nice because it allows the sort of objective measurement piece that I talked about earlier and tracking over time. So that's it for me. I want to thank all my wonderful collaborators that I've worked with, and thank you all so much for listening. Oh yeah. Well, it's mainly just faces, but you can use my email here and I can forward it to our lab director, and you can just put OCD in the email and I'll know that it's from this talk. Okay, thank you. Yeah.